In this video, we will discuss how to do the dot product operation between two vectors. Suppose we have two vectors, u and v, with n components. The dot product of the two vectors is defined by adding the products of the corresponding entries of the two vectors. It is important to note a couple of things about this operation. First, vectors u and v must have the same number of components. Second, the dot product gives us a number as an answer, not a vector. Let's consider example 1.7. If u is 1, 2, and negative 3, whereas vector v is negative 3, 5, and 2, then the dot product of the two vector is 1 times negative 3 plus 2 times 5 plus negative 3 times 2. Or negative 3 plus 10 minus 6, which is equal to 1. Let's have another example. If u is 5, 3, negative 3, and negative 5, whereas v is 2, 5, 2, and 5, then the dot products of vectors u and v is 5 times 2 plus 3 times 5 plus negative 3 times 2 plus negative 5 times 5. Or 10 plus 15 minus 6 minus 25, which is equal to negative 6. Since this involves the usual addition and multiplication, it has several properties. The first property is that the dot product of vectors u and v is equal to the dot product of vectors v and u. This is commutative property of dot products in Rn. The next property is the dot product of vector u and the sum of vectors v and w is equal to the dot product of vectors u and v plus the dot product of vectors u and w. This is distributive property of dot products in Rn. The third property is the dot product of the product of scalar c and vector u and vector v is equal to the product of scalar c and the dot product of vectors u and v. The last property is that if we get the dot product of u and itself, then the result is always greater than or equal to 0, and the dot product is equal to 0 if and only if u is a zero vector. Let's have an example. Suppose we have a vector u, which is 1, 2, and negative 3. Whereas v is negative 3, 5, and 2. If we solve the dot product of u and v, we get 1 as an answer based on our solution earlier. Then the dot product is negative 3 times 1 plus 5 times 2 plus 2 times negative 3, or negative 3 plus 10 minus 6, which is still equal to 1. This can be proven using the following statements. Suppose we have a vectors u and v with n components. That is, the components of u are u sub 1, u sub 2, all the way down to u sub n. And the components of vector v are v sub 1, v sub 2, all the way down to v sub n, where all the components are elements of real numbers. Then, we get the dot product of the two vectors, which is u sub 1 times v sub 1 plus u sub 2 times v sub 2 plus all the elements in between until we reach u sub n times v sub n. Since these components are real numbers, we can interchange their position because multiplication is commutative, giving us v sub 1 times u sub 1 plus v sub 2 times u sub 2 plus all the elements in between until we reach v sub n times u sub n. Notice that this operation is equivalent to the dot products of vectors v and u, which proves the statement. You may try proving the other properties using the similar process. Now let's try to check if you know how to perform dot products. You may pause the video and answer the following. Find the dot product of vectors u and v, whose components are given. The dot product of the two vectors is 1 times 3 plus 5 times 2 plus 2 times negative 4 plus 2 times negative 2, or 3 plus 10 minus 8 minus 4, which is equal to 1. That ends our video. I hope you learned something and have a good day.